Hello and welcome to this video on the Pythagorean Theorem. I'd like to first off start by saying Happy May. We have made it to the last month, essentially, of school and our last unit. So for this video, we are going to be talking about the Pythagorean Theorem, or as my good friend Miss Agase would say, the Pythagorean Theorem. We are going to solve for missing sides of right triangles, and we'll look at some applications of this. So please remember to write down our objective, and here we go. We're going to first start off by talking about a couple of computation ideas, and for these problems in our prior knowledge, we want to just go ahead and compute. Remember, when we have an exponent, that is just multiplying that value by itself that many times, so 5 times 5, that is 25. Here I have 7 squared plus 4 squared. Remember, that is just 49. We need to go ahead and compute the exponents before adding. So 49 plus 16, this would give us 65. 11 squared, take away 6 squared. Well, 11 squared is 121. Take away 36. And if I take away that, this will be 85. Here we have the square root of 10 times the square root of 10. There's a couple ways you can think about this. Remember, if we multiply square roots, we just take the values and then they stay underneath this, right? So the square root of a times the square root of b is equal to the square root of a times b. Or you think the square root of something times itself is just the value inside. So this would be 10. And same idea here. So the square root of 100 is 10. Here we have the square root of 64, or root 8 times root 8 is just 8 itself. For the Pythagorean theorem, this says, in a right triangle, the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. So some keywords here, we have legs, and the legs are the sides that form a right angle, meaning 90 degrees inside a right triangle, and the hypotenuse. Hypotenuse, I'd like you to say that word, hypotenuse. That is the side opposite of my right angle. Pythagorean theorem, this is just a squared plus b squared is equal to c squared. The converse of the Pythagorean theorem is also true. So if we have a right triangle, a squared plus b squared is equal to c squared, and then additionally we can prove that a triangle is a right triangle if a squared plus b squared is equal to c squared. So this being true also implies that the triangle is a right triangle. For right triangles, the side opposite is the hypotenuse, and it's always the longest side. So we're going to go ahead and start off with this idea. This is one of the key mistakes applying the Pythagorean theorem, is that students often misplace which side is A, which side is B, and which side is C. The other sides, right, these are the legs, and So we're going to go ahead and we're going to mark up this triangle as A, B, and C. A and B, it doesn't matter. If the legs are A and B, you can go ahead and flip-flop those. C is the side that matters the most. Okay, so when I apply the markings of A, B, and C to my triangles in our right triangle application problems, the side that's the hypotenuse must be C. A and B, you can go ahead and switch. So C is the only one that matters, and it's always across from the right angle. So looking at this, here's my right angle, side directly across, this is my hypotenuse. So we want to go ahead and we want to identify the hypotenuse on this problem. And this is not in your notes here, you're just listening. This is kind of just a visual identification problem. So I'm looking at my triangle. Which side is the hypotenuse? Well, here's my right angle. The side directly across is my right angle. So therefore, side AB is the hypotenuse because it is across from the right angle. Okay, and that's how you identify it. So I want you to pause the video right now. I want you to go ahead, read this sentence frame to yourself, identify the hypotenuse, and justify why. Okay, so hopefully you've tried this. The side directly across from my right angle is the hypotenuse, and this is side RS. And our justification is because RS is across from the right angle. All right, easy enough. Okay, so let's go ahead and talk about kind of applying the Pythagorean theorem. It describes the relationship between the sides. So here I have a squared plus b squared, and that's going to equal c squared. We can only use the Pythagorean theorem if we have a couple of requirements. One, it has to be a right triangle. I need to know it's a right triangle. And then two, you need to know the lengths of two sides. If you only know one side length, it doesn't really help you much with the Pythagorean theorem, unless you're given additional information about congruency and something like that. But you need to know that it's a right triangle, and that you need to know the lengths of two sides. Okay, so we're going to kind of quiz you on this idea. For which triangles can we use the Pythagorean theorem to find a missing side? I want you to just think about it for a second, pause the video, and kind of identify this, and I'll go over this. Alright, so hopefully you've tried this. Here for situation A, notice this is a right triangle. Okay, so I guess requirement number one is satisfied, right? I have a right triangle. Situation two, do I know two sides? Well, I know this side, and I'm given one angle. In this situation, I do not have the information needed, so I cannot use Pythagorean theorem for here. Situation or problem B, I have a right triangle. Okay, it's a right triangle, and situation two, I have two sides. Okay, so we're good. I can use it then. Here for problem C. Do I have a right triangle? Well, I'm not given any information about it being a right triangle. I'm not told, right? I don't have this little box here telling me that this is a 90-degree angle. So therefore, I cannot use the Pythagorean theorem on that problem. Okay, on D, so problem D, here I am told it's a right triangle, so I'm good. And situation two, I am told that this side length is 2. I'm also told, though, that I have this side and this side that are congruent, and that's what that little line means there. So if this side is 2, that means this side is 2. Therefore, I have information about two side lengths, so I am good to use the Pythagorean theorem for these two problems. Alright, so we're going to go ahead and determine the length of a missing side. And for this problem, for these two problems, we're going to go ahead, please take notes with me. The first thing I'm going to do is I'm going to label my sides. I'm going to label this side A. I'm going to label this side B, and the side across from the right angle is always C. So now I set it up in my equation, a squared plus b squared is equal to c squared. A is 5, so 5 squared plus b squared is equal to c squared. That's 12 squared. So computing this is 25 plus b squared is equal to 144. I'm going to isolate b, so I'm going to subtract 25 from each side. And this gives me b squared is equal to 121. So if I take the square root both sides, I get b is equal to plus or minus 11. Since we're dealing with lengths cannot be negative, so we're going to throw away the negative answer. So therefore, this side is 11. That's our answer. Doing it again, I'm going to go ahead and label my sides. I'll label this time this side A and this side B. Schwarberg, why did you label this side A and then the unknown side B over here, and I flipped it here? Well, the reason why is that I can interchange A and B. It doesn't matter. The only side, again, that matters is the hypotenuse, and that being C. So I'm going to go ahead and fill out the Pythagorean theorem. The Pythagorean theorem. A, B. I just want to do it in a different color to kind of help make it obvious. So A squared plus B squared is equal to C squared. Well, A is unknown, so A squared. B squared is 6. Pardon the bell. And C squared is 10. So I have A squared plus 36 is equal to 100. I subtract 36, pick up sticks on both sides, and I get A squared is equal to 64. Taking the square root, right? And square root undoes our square, so that cancels that, and I get A is equal to plus or minus 8. And again, we only keep the positive value because we're dealing with lengths, so therefore A is 8. For the next two problems, I would like you guys go ahead, please pause the video, try these on your own. Okay, hopefully you have tried these problems. Looking at these two problems here, I'm told that this whole side is 6, which means that this side here is 3 and 3. So I'm going to go ahead, and if I want to solve for this side, this is going to be A, this is going to be B, and this side will be C. So I get A squared plus B squared is equal to C squared. Well, A is 3, B is X, and C is 10. So this gives me 9 plus X squared is equal to 100. Subtract 9 on both sides to give me 91. And we'll get X squared is equal to 91, which means X is equal to the square root of 91. Okay, if I calculate this in my handy dandy calculator, this gives us approximately 9.5. Okay, and again for this side, same idea. This side is going to be 15, so I get 15 squared plus X squared is equal to 20 squared. Here you're gonna need your calculator for these guys. So this gives me 225 plus X squared is equal to 400. I subtract 225 from each side. And this gives me X squared is equal to 175. Take the square root of both sides, and this gives me, one moment, let me plug this in, we get 13.2. So X is approximately 13.2. Okay, we'll move on to those problems. We'll do those later. But just for closure, when can we use the Pythagorean theorem? We can go ahead, we can use the Pythagorean theorem when we have to have two pieces of information. It's a right triangle, and you need to know two missing sides. Alright, hopefully we accomplished our objective, which was to use the Pythagorean theorem to solve for missing sides of a right triangle. Don't forget to fill out the Google form, and as always, Schwarberg out.